Okay, thank you very much for being here. I'm Marco Tognon. I'm a senior researcher at the Autonomous System Lab at ETH, and today I will present this project that has recently started together with Microsoft about the use of mixed reality for shared autonomy. So in many of the nowadays applications, we can either find like a task performed only by humans or only by robots. And this is mainly for safety concerns. So when we have a task that requires high level of reasoning and decision making, then human operators is the most likely the direct solution, because they can bring experience and some training skills. On the other hand, when we have a task that instead requires precision, speed, and repeatability, then most likely robots will be used thanks to their great power and mobility. But of course, on both cases, we have drawbacks. Like humans have some limited mobility and power, and in many applications, they also are in danger to be physically harmed or for exhaustion. While on the other side, of course, like robotic systems, most often requires control environment, and for complex tasks, they lack in decisional autonomy. What instead we foreseen is application scenarios where humans and robots can cooperate with each other, can work in the same environment, showing or reaching a high level of shared autonomy, where basically every agent, either the human or the robot, can operate completely autonomously or in cooperation with other agents. So we would like to bring together the good properties of humans and robots at the same time, combining the two systems. But however, there will be we need to face different challenges related mainly to the safety. So nowadays, the investigation of shared autonomy mostly focuses on grounded manipulators. This because they are kind of stable systems, so then it's much easier to start analyzing these problems. And also, they have a large force torque envelope, such that allows to basically help humans in very burden operations. But of course, they are also limited in workspace, which in terms then limit the scenarios of task that this shared autonomy could allow to do. What we foresee instead is to basically extend shared autonomy to mobile robots, and in particular to aerial manipulators. Nowadays, aerial manipulators reach great capability in terms of full pose controllability, flexible physical interaction capabilities, and of course they have a sort of theoretically unlimited workspace. But on the other side, the investigation of human-robot interaction in the aerial robotic community is really poorly addressed so far, likely due to the safety concerns. Motivated by the lack of investigation in human-robot interaction in the aerial community, we already started working on this problem, both considering interaction with the teleoperation, where human and robots are located in different locations, but also when human and robots share the same environment and they even physically interact together. In these preliminary works, we show the feasibility of human-robot interaction even with aerial robots, but still the autonomy level is really low, and of course we need to improve the safety of the system. And to reach this goal, many challenges has to be addressed. The first, as I said, is the safety. So we need to guarantee that the robot itself and the interaction with the human is stable. And this is not an easy task, because the human will have to interact with a sort of dynamic and uncertain environment, which includes the human. And not only that, but at the control level, the robot should be able to have some awareness of the human behavior and comfort. And for this, for example, we think that it's a very important point that the robot is able to recognize intention. So what we will investigate is how to use some human-robot interfaces to basically being able to interpret user commands. And on the other side, the robot should also be able to provide additional information to the user, for example, related to its own state or the state of the environment, again, using adequate human-robot interfaces. So to address all these challenges in this project, we will first investigate what are the human-robot interface that are the most suited for this kind of task. And we will design new methodologies to identify and recognize human intention to control the robot, and on the other side, to provide additional information to the human to augment his environmental awareness. And since we will mainly focus on aerial robotics, and a particular point to which we will have to give a lot of attention is the safety. Making sure that in all these interactions, the robot always guarantees the safety of itself and the stability of the interaction. So the first, among all the interfaces between human and robots that we can find, examples are remote control, which are mostly the mostly known and available, but on the other side, they don't provide any feedback. There are no means to provide feedback to the human, and they are also somehow non-intuitive and so addressed for only professionals. To provide some sort of feedback, we could use some haptic devices, but also in this case, since they are some kind of intrusive setup, they somehow limit the mobility of the user. And to reduce this problem, wearable devices have been proposed, but also in this case, they are somehow a physical barrier between the human and the robot. Instead, we believe that virtual reality or like mixed reality devices could really bring a step ahead to the human-robot interaction, because it will allow us to use multiple communication channels and somehow does not bring any limitation in the mobility of the human. So what we would like is to basically to reach a system with a high level of shared autonomy, where the human operator and the robot can cooperate together and perform a task together that goes from the task description, go all along the task planning in a cooperative way, perhaps some task replanning where the human, for example, can help the robot to find better solution, and finally a cooperative way to perform the task. In particular, what we will analyze is all the different communication channels that can be used, for example, speech, gesture, eye tracking, and mixed reality manipulation to control the robot. And especially the last, together with sound, will be also used to provide additional feedback to the human. And in particular, we will understand which specific communication channel is the best suited for different type of modality to control the robot. In fact, according to the specific task or situation, the human might need to control the robot at different levels. For example, range control for very low level control, or velocity, trajectory, or action control going toward a more high level control for the system. Here is an example where, thanks to a mixed reality device, the user can basically command or can modify, can both visualize and modify the end effector trajectory of the robot. This considering this type of modality. Or if we consider a higher level modality like action control, then here again, using this powerful mixed reality tool basically using speech and ACE tracking, the user can even command a high-level action like pick an object or place the same object in a specific location. But as I said, we believe that in a real scenario when the condition may change in real time, the user must have the capability to basically change the modality in which is interfacing with the robot. So if from one side we would like to always maximize the robot autonomy to basically limit the human tiredness and stress. On the other side, we also want that the human is always able to basically get full control of the robot, for example, for safety concerns. But going from one level to the other, or in every change between one modality to the other, we believe that it is really important to consider the human comfort and his current attention level. And whenever we change, it's very important that again we ensure that the system will stay stable. And this is not a trivial task, since because of the switching nature of the system. And so to conclude, what we would like to investigate and to reach in this project is the ability to use this mixed reality tool to improve the shared autonomy level, basically to combine the good properties of human, meaning high level of reasoning and decision making, with the good properties of robots, being precise, speed, repeatability, mobility, and power. And for this, again, we will we will analyze how we can use mixed reality interfaces, trying to exploit all the possible communication channel for the different autonomy levels, and using it as well to provide visual feedback to the user. And again, as I said before, we really would like to provide the user the capability to switch between one autonomy level and the other, going from a very low level control to a more task-oriented control. And all this switching should aim somehow at both the safety of the system, at performing the task, but also at optimizing the comfort and the stress level of the human. So the project will be carried out mainly by Mike, that is a PhD student in our lab. Unfortunately, he was not able to join today, together with the supervision of myself, Nick, and Roland from ASL, but also Juan and Jeffrey from Microsoft. Thank you very much for the attention, and I will be glad to reply your questions.
Thanks for the talk. I have a quick question. Allowing the human to make more high-level decisions would enable them to manage more robots at the same time? Like if I imagine a factory worker managing 20 drones doing stuff. Are you also considering the case of switching between robots that one human manages? And, you know, like just, yeah, that's the question.
Yeah. I mean, no, probably not in the context of this project, because here we really would like to focus on the switching between high level and low level, but definitely the capability at the high level point to say I want to control either like one robot instead of another. This is definitely a possibility. Imagining having, I don't know, a spot or a ground robot and an aerial vehicle. When you interact with the system, it would be nice to really have a real interaction, not between single agents, but between a team between the full team. And we see basically the human as the master chef of the team, but we can even think of applications in which there are more humans, and they can both cooperate with each other, but also helped by robots. So like this, of course, is a very long-term vision, but I really believe that the improvement of the interaction between human and robots then will unlock, let's say, more complex scenarios where multiple humans can cooperate with multiple robots.
I have a question on the slide where you showed the video of manipulating the trajectory for the robot arm. So just curious whether there was a particular reason why the manipulation was done at the distance, kind of pinching, but the ray goes to the trajectory far away, and not actually going and physically drawing exactly at the spot. Because when I use VR, for example, like on Oculus or something, then when you need to use this ray kind of to manipulate something, it's usually much more difficult because all the movements are amplified. But if you go and draw, like, okay, move from here to here, instead of going kind of tracing, just from intuitive level. So just curious whether that was just a setup or there was a reason for that.
Yeah, no, that was just a visual example to kind of give you an idea. We were not the authors of this work. Honestly, I think that, as you said, like really interacting in close with the trajectory is of course probably the most precise way to modify the trajectory. I guess that sometimes, again, as I pointed out during the talk, the safety concern is also a primary thing to always be considered. So we just started this project, and perhaps in next year when we will present the results, we could better reply to this question, because especially us foreseeing interaction with aerial robots, then getting very close to those systems can be of scary from one side, but also of some safety concern. But hopefully our work will somehow bring us also in that sense able to really get close to aerial robots as well.
Okay, do we have any other questions? If not, let's thank the speaker. Thank you.